Alright, so in this video series we're talking about rational functions. This is basically the culmination of chapter 5.6 and a good bit of the reason why we've been spending all this time talking about polynomials. The graphs and the functions themselves can look a little bit intimidating, but we're going to look at them little piece by little piece. We're going to find the domains of our rational functions, identify vertical and horizontal asymptotes, do some sketches of our graphs, and finally talk about a few applied problems. Okay, so as we know, or as you may remember, a rational function is a function of the form f of x equals p of x over q of x. So it is a quotient of polynomials. Okay, so we've been spending a lot of time with polynomials recently. So those parts aren't anything to be worried about. The whole thing's not really anything to be worried about, right? But we do have this additional requirement that our q of x, our denominator polynomial, can't be equal to 0. So therefore, our domain, we're going to take all real numbers and we're going to throw out any values which make q of x equal to 0. So for instance, we have this one. We have f of x equals x squared plus 4 over x times x minus 4 times x minus 2. And we know from what we've talked about polynomials that if any one of those factors in the denominator is equal to 0, then the whole denominator will be equal to 0. So we know that we've got to exclude x equals 0. We've got to exclude x equals 5. And we've got to exclude x equals 2. So our domain will be everything but those three values. Okay, so we're going to look at our most simple rational function, which is 1 over x. Of course, this is one of our toolbox functions from earlier, but we want to look at it now as being a rational function, right? We have a boring polynomial of 1 over a boring polynomial of x, right? So our domain, we are going to have to throw out x equals 0, right? If we write that in interval notation, of course, negative infinity to 0, not including 0, union 0 to infinity, again, not including 0. And this graph has two main interesting features. We have a vertical asymptote at x equals 0. So we'll write that. And we have actually also a horizontal asymptote where you can see the graph is getting closer and closer and closer to y equals 0, but it doesn't ever quite get there. So that is a horizontal asymptote at y equals 0. And those are really the only two interesting features on this graph, to be honest. Oops. There we go. Okay, so that's a good place to break, and we'll start the next section talking about vertical asymptotes.